Yes, I needed the oxyhail to get the nitro powder, but there's no guarantee it'll lead me to anything either. I need 40,000.
Please set bitrate less than 6,000. Okay.
The bottled fairy. Just so I can have something in that slot, even though it sucks. Alright. Should buy some items, I guess. That is not the item shop. Don't have any potions at all. Okay. Okay, this way. Let's go back to the desert quick. Get the caravan, get the fairy in a bottle.
Nope, still out of control. Huh.
Wait. Am I in the right place? No, it's the other side. God damn it.
Okay.
It's over here. It's a completely different desert.
Okay, there we go. Now,
Sorry, when I
Restream is
this
not
game in
complaining
desert,
about
I
that.
automatically think of Mirage Tower.
Ooh, man. It's going to be very motion sickness for a lot of people. Oh, that's cool. Got that underfill. Ooh.
Okay, that was actually a bottled fairy.
Okie doke. Let's see here.
Next we're gonna go to the
Then we've got a battery. Okay. Well, I should definitely close that. Do I have Restream chat going?
Okay. One more crystal to go. Even so, we still need to find the loot as well. We need the 4 crystals activated and the loot.
Probably should mute my mic for a second here. Ooh, excuse me.
There. That's Gaia. Well, let's check out the stuff while I'm here.
Oh.
Holy! Haha, get it. Can't learn either of these. Kira, oh my gosh, finally. Alright, weapon and armor. Ruby armlet. What's over here? No. I'm insulted that you even offered. And the items, then we go to the fairy spring. Might as well. Adamantite. Huh. Okay. So that's another thing for dwarves, right? No, adamant... Wait. Right.
Oh, okay. Enough procrastinating. Okay, here we go. Oh, let's see. So I'm suspecting that there's dead shorts somewhere in the secondary. Somewhere in here, anyways. So I'm going to turn this to beep mode. And let's see here. Okay. Oh, hey, hello. How are you? I did notice my mic was muted, so thanks for saying something, anyways. Unfortunately, one is in Sweden, so he is possibly sleeping right now. Okay, so basically, I think I'll trace this water damaged board down to a short somewhere. So I'm just going to check these converters. Yeah, those are acceptable. Can't seem to get a... Let me just... I mean, it is... Maybe I just need to scratch away some of this. Usually I get a charging... Let me just discharge. There we go. Okay. Usually I get a charging reading out of a capacitor, but it could be that this... Oh no, the capacitor is not short to ground because it's... But it could be open to ground, which doesn't help. Okay, so this is a true diode though. So it should have a 0.7 at least. Interesting. Diode's not dropping anything. Wonder if we have our culprit. Okay, that's charging something. Yeah, okay. Nope, that behaves like a capacitor. Oops, that's out of view. Sorry about that. Oh, let's see here. Okay. Now, can I get that better focused? I got a macro conversion snap-on for my DSLR, so I've been able to stave off the $600 microscope gremlins. Okay, yep, that's behaving like a capacitor. And this should be a resistor of some sort. Yeah. Okay. Let's see. I think another spot that got hot to the touch was the audio IC, which is over here. It's this guy. Now, it didn't take down the 3.3 rail, so perhaps it is not faulty. But that's okay. That's okay. That's okay. That's okay. Yep. Still good. Yep, still. The only other thing that was really questionable was the eMMC. I suppose I could just hot swap. You know, yeah. So these 0 ohms are okay. Yeah, and that's behaving like a capacitor as well. Yep. Or rather, a capacitor tied to ground. Yeah, these are acting like series resistors. Hmm. Yep. Hmm. Oops. This is a mystery. Oh, I guess the other thing, right? I don't have the ability to. I don't have the ability to have the eMMC plugged in and test the Wi-Fi because they've integrated it into a shield. So I was going to go into KiCad and try to draft some sort of extension cable because the connectors are widely or are well known. No, they say 10 degrees is okay for popping the connector, so I think that's an acceptable. I mean, I think the connector itself looks fine. I mean, at least on this side, and then here. Oops. Hope I'm not making you motion sick. I think this side's okay too. Oh, what's this? Is that just mineral deposit, or maybe I should just check for shorts on this on the board itself. The thing is, it wasn't shorting out in live testing. Yeah, so that's capacitor to ground. Capacitor to ground. Yep. Yep. So those passives are working out. Let's see here. Oops. Sorry about that. There. Apparently, you can back up and replace the eMMC. I'm curious if you can, if you have a totally corrupt or remake an EMC. Okay. Oh, I see. Right, you still have to extract the keys from the security chip in order to, okay. So you, oh. So if this eMMC is actually dead, well, maybe I can just see if I can find something wrong with the wireless section. Oops. The the problem with the macro lens, like every microscope, is or anything microscope adjacent, is that you're only about 10 centimeters away from your. That's not a good sign. What is that? Oh no, that's fine. Let's see. Nope, that's okay. I'm measuring the 3.3 rail, if I understand correctly. And this should be, yeah, okay. That's just an inductor. Yep, that's behaving like a capacitor. That's behaving like capacitor. Yep. Okay, so this specific capacitor is not tied to ground, so it must be DC blocking something. I'm not sure what. That's still behaving like a capacitor though. Although that just touch the needles just in case. Oh yeah, okay. I just missed. It has a faster charge. Okay, let's try that again. Yeah, okay. Well, so far so good. Now we're into the RF section. These are... Now, I know this, like 1, 2, 3, are supposed to be RF switches, according to the data sheet of the Wi-Fi chip. That's a very low resistance for a resistor. It's a very low resistance. This is sus. Very sus. Is 50 ohms considered low for this guy? Let me just see. Because I would assume that these would be terminating resistors of some kind. 0.7 ohms. That's... something is very sussy. Oh, these are not resistors. These are likely inductors. Yeah, that makes sense. It is an RF stage after all. Okay, let's go back to... Oh. That does not look like an inductor. Let's see if I can zoom in. I don't think I can zoom. I forgot how this works. Oops. In terms of focus and zoom, I don't think I can zoom anymore. I may have to pull out the camera, which means that I don't get to share with you. That does not look like an inductor, but if that is shorted out, then that may explain why stuff's not happy. Because it is shorted to ground on both sides. You know what? Let me just check the board view. Unfortunately, also off camera. Let's see here. Yeah, that's it's a series. Looks like it's a series component. Now how do I rotate? Oh, F or G. Okay, F. Yeah. Okay, so I've got the the depopulated PCB. Yeah. Okay. So that, let me just verify. Yeah, that little guy. Okay, you've got an inductor to ground. And what is that signal path? Pretty sure I have the board in the right orientation. Oh, no, I don't. This... Does this have a different layout than... Or do I just have this board? No, I don't have... Oh, this must be a V1 switch. Let me see if there's a V2 switch board view somewhere. V2 switchboard view. Work for me, Google. Yes, okay. Yeah, so it does have a different layout. Okay. Oh yeah, so the not only does it have a different layout, it has a different has different filters here and here versus a V1. Huh. How do I know what function this thing is supposed to have? I mean, do I not have? Just trying to see. Can I get more focus here? I'm just trying to see if I can see the PCB traces. Because that's clearly, like, you can clearly see that's an RF, and that's a T-shaped. Like, if this is in the signal path to the RF, then this is a T-shaped filter, which means that this is a capacitor, this is a capacitor, and this is an inductor. Which means that if this capacitor is shorted out, then we have a problem. But it looks like this big guy is supposed to be part of that path too, if that. But again, I don't have a board view to see the. Yeah, the. Just trying to think here. Why would both of those. Why would both sides short to ground? It shouldn't, because it's a DC. Oh, no. The inductor. Oh, right, I'm getting fooled by the inductor, because the inductor should be short to ground. Or should be very tiny resistance to ground. Okay, so I'm going to the lowest range possible on my... Yeah, for 3.4 ohms. That makes sense. Yeah, okay. So there's probably nothing wrong there. Man, this is worse than a cruise ship. Man, I've gotta get some revenue. So I can get out of this creaky IKEA stuff. Okay, that's right. So that's why this beeps, is because it's an inductor to ground. So the joys of diagnosing RF circuits. Yeah, so this is likely an inductor as well. Yeah, unfortunately, you're left with when it comes to filters and using standard architectures, you're kind of stuck using a spectrum analyzer to go through each one of these paths to see if you've got appropriate signal levels. So let's stay out of the RF stage and see if we can... Well, that's fine. Oh, sorry. Okay, that's fine. This... Yeah, okay, so that one's fine. That one's fine. Okay. Right, so this is a series. I suppose what I should really do is just completely depopulate the RF stage or the area of a board which I know is bad. Oh, I don't know why I'm testing pads or unpopulated pads. Yeah, that's RF stage again. I don't know what this thing is, but I did realize they went off book here and only used 3 RF switches instead of 4. So I'm not sure what this thing is. Could be another RF, but or another RF switch, but I've never seen one with 8 pins. Maybe it's got more inputs and outputs. I don't know. Let's see. Yeah, that could be a fun activity, is taking off all the parts off of a version 2. Because yeah, that's right. I have two version 2s where the main CPU is shorted. So basically, oops. Like, the only reason why I'm pursuing this one at all is because the main CPU is not shorted. Yeah, the reason why the way I got to this conclusion was that the power rails for the CPU were shorted before I removed them. Then I removed the CPU and the short went away. So that's how I concluded that the CPU was burnt. But I was kind of curious if it was just because if there was just like a little component failure on the top or something. But nope, so far so good. That's actually kind of interesting. All of these are behaving like capacitors. There's no short circuit. So I wonder if it was just like a temporary bridge underneath the CPU, which would mean that reballing it would be an appropriate fix. Because all of these are not shorting. They're behaving like... Oh, except that one. Let me just turn that to resistor mode to see if those are actually resistors. Oh, okay, yeah. So they're just 16 ohm resistors. That one, or at least that one's 16 ohms. This one looks like it's hovering around, oops, hovering around 13. It seems to be going up and down. Okay. Well, back to beeping. So these must all be, okay. I might need to calibrate the colors on this thing, because are these all capacitors here? Usually you can tell what the component is by just its color. Oops. That's behaving like a capacitor. Same with that one. Okay, so it looks like whatever this reddish brown or light tan must be low resistance doodads. Oh, well, I'm glad you're I'm glad you're starting your learning journey with me. Now this, of course, I have no clue. Let me just clean off all this humid flux. I like to call it humid flux. Basically, it's flux that was exposed to humidity and is pretty much harmless when you see it in a product. There. Okay. So it looks like I don't. Looks like I did not create any shorts when I took this off. Of course, what pins do? Oh, interesting. I guess I did rip off a couple balls over here, so I cannot put this chip back to its original board. Not that I kept track of. Let's see here. So yeah, there's a few other Twitch streamers that do this stuff too, but they're not. They don't have my background. They're more repair tech up. I'm electrical engineer and working downwards. Although technically I'm not an electrical engineer, I only have a 3-year diploma. But let me just shout them out. I think this is the right. Now, Coder is UK based. He's been streaming for 4 years. He's getting close to 100,000 on YouTube, and that seems to be his primary growth sort of platform. But he I think he does simul streams, like he streams to both at once. Not partner yet, but I think out of the repair community, he would be the most likely to get partner. Let's see here. Now, there is California-based David owns a used game store and repair shop. I have to get his. They're both primarily YouTube streamers. That's where they're seeing the most growth and attention. Let me just get his Twitch username though. Guess I have to go to twitch.tv. But let me think here. I think Computer Booter started his business in Carmichael, California. In 2015, and has been pretty successful. I mean, he rents a space and has 2 employees, so can't complain about that. I've also not been mindful of my OBS scenes. Okay, so computer booter. Okay, it is one word. All right, so computer booter. So you'll want to, yeah, you'll definitely want to join their communities you might be able to absorb a lot. There's a lot of shit talkers, but, so what do you mean by bulky stuff? Like simpler, larger components, or higher power things, or I'm assuming that's what you mean. Yeah, microsoldering is definitely not something you just jump into. I personally got eased into it as well in my old job, doing RF stuff. But yeah, what was I doing now? I lost track of what I was gonna do. Right. I was trying to see why these may or may not have failed. But yeah, well, yeah, and then since I lost track of which CPU came from which boards, I basically can. Oh yeah, okay, yeah, get the basics down, and then and then invest. So are you going to go to school for electrical, or I'm personally trying to transition out from a desk job because it's just not healthy to sit at a desk for me. My body has a tendency to conserve energy, so I really need to have a job where I'm on my feet all the time. So I've decided to try to become an electrician. uh, Now let's see here. Um, so this is one of the boards. I don't know. Um, I mean, you have to go to college for apprenticeships in Canada, anyways. So whether you, oh, this might be the one I'm talking about in terms of ball rippage. Yeah. Oops. Sorry about that. Yeah, so I ripped the pads off here. Okay. So I guess the CPU would match with this motherboard if I actually wanted to repair these pads. But anyways, I guess the idea here was to. I mean, I think, like, for me, I went to community college, which is where the 3 year comes into effect. You can still have a decent career going to electrical community college wise. But of course, I don't know how it works in the States in terms of job placements and whatever. But I mean, I eventually landed a job where I was making like 36 an hour. So, you know, not as much as an electrician, for after 6 years, but I mean, it's pretty close. Although I'm essentially starting at the bottom again with 6 years. Or it would be 5 years if I start my apprenticeship. Ah, interesting. This is complete. Oh no, no, same. But yeah, I wouldn't say don't let those college people talk over you above. I think when it comes to just people talking above people's heads, it's just uh, information dissymmetry. Like if you can learn stuff quickly and the stuff sticks, then I think you're just as good as a college person. I wonder. Well, let me fire up the hot air station, and because it might be fun to just like recycle this chip. Because I'm assuming that it itself is not shorted out. Let me just double check that. Yep, that's fine. Yeah. So let's see here. The Yeah, well, I mean, people learn different ways. Um, yeah, I mean, with the way I see it is, do you even need to go to school anymore? Like, basically, you could probably watch 100 YouTube videos and have the same knowledge as someone who went to school for like a year or two. You know, like a really good. Oh no, that's tough. I was gonna say you should watch EEV blog, but then I realized a lot of his stuff could be academic as well. But I think there's some, like, if you go back like in his catalog to like 7 years ago or something, he really starts at the basics. But yeah, I guess there are some like really basic safety things like um, how not to poke things. um, yeah, let's see here. But I'm just curious. Yeah, so this would not be. Is not quite set up. I have to change my nozzle to no nozzle. But yeah, if you want to get into electrical repair, then there should be like a 2-year college program that's out there for you. Because unfortunately, I think at least in the United States and Canada, it's still kind of credentialist. It's not as bad as Korea, but yeah, unfortunately, some people really want to see that piece of paper. Let's see here, so I can turn the station on. Bring that up to 400. Well, we're going to go quick and fast. We don't care what happens to the parts, so I'm going up to 500. Nah, yeah, 500. And I'll get a piece of rubber I don't care about. And then let's see here. Yeah, I want to choose my flux carefully. No clean. Oh, it is no clean, eh? Never mind. Like the halogens in the halogens in flux are what kills the solder mask. But no clean is typically low halogen. Well, we know that this is lead. Yeah. It depends on the industry. It really does. Sometimes you can't not have doctorates, unfortunately. And yeah, doctorates, it's a really awful grind to get all the way to the end, because not only do you have the 4 plus 1 to 2 plus another 1 to 2 years, you have to be well funded. You have to be somewhat independently wealthy or well funded outside of school, or else you're essentially working for less than minimum wage during your master's and your PhD. Let's see here. So what? This should be enough flux to get. So yeah, basically I'm just going to blast this thing with a ton of heat. I'm just turning my nozzle side, or I'm running it with no nozzle essentially, but I'm just turning it sideways to blow the flux around, because you do want it to get on every component. Okay, now I do want to get in. Trying to find my tweezers here. Here we go. These should be acceptable. I'm gonna try unfortunately, I have to sort of block the view because I don't have any 45 nozzles. Yeah, okay, well, I mean, mechanics, at least in Canada, mechanics can charge 100 an hour. 130 an hour right now is the going rate. So again, I think that's like a 4 to 5 year kind of thing, you know. But to be honest, like, there's no reason why going electrician or, you know, some sort of 2 year, 3 year trade certification is a bad thing. It'd be nice if your dad would buy you all those toys. It would definitely be a great advantage. Um, but yes, definitely. If you want to get into repair and have access to independent wealth, then you should buy like banned consoles and sort of like, yeah, you should buy banned consoles from eBay and practice on those. Dang, this thing loves to soak up heat. Maybe I should have started up the board heater too. Perhaps this is better heated from the bottom. Like, this is a destructive disassembly, so I'm not too concerned. Oop, here we go. Nice. Can we get rid of the shields? Can we get rid of some of these parts? Nice. Okay. Trying to figure out where all my tweezers went. Here we go. Let's get that out of there. Oh, sticky flux. Come on, shield, you can do it. Bye-bye filter. Whatever those things are. Ooh, stubborn. Stubborn no more. Come on, shield. There we go. Now I can do some productive sweeping. Actually should rotate my tweezers so I'm actually sweeping. Bought some welders. Oh. Oh, interesting. That's a neat project. I thought oh, I guess the old welders were cheaper than a new single phase. Just checking to see if there's anything left on here. Okay. Oh, seems to be something over here, maybe? Oh, I guess that's a reflection. I think that's everything. Okay. I can put this away now. And then, I'm just going to go off camera a second, or leave my station a second and get a toothbrush. We can get rid of all this burnt flux. Okay, is that clean enough? Little Wi-Fi chip. Can't get super close, but I can get reasonably close. Okay, so let me just turn on my... Maybe I should have bought that stencil from AliExpress. Oh well, too late now. Oh, technically not too late. A 3-phase generator. That does sound fun. Yeah, I don't, trying to think of who even welds on Twitch. I don't think, the only thing that comes close are people who work on cars. Of course, they're not my favorite to watch, so I tend to just not bother. Okay, now let's see if I can. Whoops. Oh. Okay, let me just rub the tip of my iron in the brass sponge. There, okay. It's very easy to get this thing out of focus, eh? Pretty sure I disabled autofocus. Yeah, unfortunately the bottom of this board is capped on, so you really can't stand up to the heat. And of course, without having a real microscope, I don't think this. I can tell if I've really sucked up all the solder or not. Okay, well, I'm gonna let's see here. Where's the lead? Lead, where are you? Oh, there you are. No, I definitely see the thing is just trying to think here. Based on what I know about generators, I'm curious what it can tell you about. I mean, it would definitely tell you about power electronics. There we go. Okay, now to I mean, personally, I would take a electronic project that couldn't kill me. But I mean, welding is definitely a useful skill to have anyways, regardless. Come on. Silly flux. There we go. Well, I don't know what I'm going to do with this chip. I don't know if it works, but I have it anyways. Just for fun. Yeah, I expected the generator to be mostly through hole. But I think if it got fairly complicated in terms of computer control, like the sine wave generation, well, I wonder how they implement the sine wave generation. Like normally what or one way we did it was we just used a square wave and then filtered it so that we killed all the high frequency stuff and you just get the one frequency you need. But at 60 hertz, it's gonna be those specific components get really massive. So I wonder if if they're just trying to get by with a square wave. The industry calls it modified sine wave. So it's really just a square wave at 60 hertz. But I would expect the generator to have some pretty beefy MOSFETs in it. SMT boards. Okay, now with this guy did. Oops, that's not what I'm after. No, there's still some O201s here. Oops, still some O201s here I need to scrape out, like that inductor. Gone. Oh, whatever this passive was, gone. I think that should be clean enough for a photo now. I think whatever's obvious is obvious. Interesting. So it had a. I'm still super curious what this thing was, this 8-pin, because there's a gap in the ground plane, which means that was it like some sort of transformer? That's so weird. but it's definitely some sort of sub-circuit of the Wi-Fi chip itself, because you can see that it has a path. This is called a pi network, by the way. The thing left of my because you've got, if I rotate it this way, it looks like the symbol, the Greek letter pi, capital pi. So you've got a shunt series, then shunt. You've got a pi network. It goes into this mystery chip, and then it comes back out with a series something back into the Wi-Fi chip. Fascinating. But anyways, yeah, and these are definitely behaving as some sort of RF switch. So you've got two inputs, one output. And I forgot what this was. I thought this was a filter of some sort, but I could be wrong there. Whatever the data sheet says, it's a whatever for its role. But yeah. Anyways, I should try to get as good of a still picture as I can out of this. So please bear with me while I change out of movie mode. And that was the main power switch. I think this is the mode switch. No? This? Yes, okay. Okay, let's go to idiot mode. There we go. Okay. Can I get a good... Oops. Nope. Okay, so I can't zoom in that much. Can I do that? Nope. Oops. Okay, so this is... I guess this is the best... Hold on a second here. I kind of wish they had the super zoom mode inside of the movie mode, so I could tell when my live... Of course, I have to steady my hands here. Sorry about that. I think this is the best focus. Okay. It's writing to the SD card. Just wait for the right light to go out. Good. Alright, play. That's not a bad photo, eh? What do you think? And I've got the RAW too, so I can play with the color profile to really get the traces accentuated. But, yeah, that's interesting. Okay. It'd be nice if I could get like a real good zoom on the bottom left there. There's a differential pair. Because my assumption was that it wasn't connected, but I think the multimeter says something else. Now, are there any solder blobs? Just scanning left to right here. Are there any solder blobs that are bridging any pins? No, I don't think so. And it looks like I preserved the solder mask, which is nice. What might be useful is if I do go over it with a braid. That might be smart. So let me just get some braid out and flatten those pads. Sorry, let's just go back to live view for a second. You'll have to excuse the frame rate because I don't want to go back and refocus everything again. Okay. What's this kickstand doing here? Weird. Oh, it must be loose. Well, I'll just put that over there for a second. Where did my collection of braid go? Sorry, you'll have to bear with me here. Oh, it's below my multimeter. Okay, so that's not the diameter I wanted. Here we go. That's what I'm after. The great thing about this MG Chemical stuff is that the desoldering braid comes preloaded with flux. The cheap Chinese stuff you get on Amazon, etc., doesn't have flux, so you have to keep squirting it on. And yeah, I think, as I said earlier, some fluxes are a lot harsher than others, even though they're sold as electronics safe, and they can eat away at the green solder mask, which is bad for parts replacement and avoiding short circuits. And I just need my side cutter, wherever that went. Side cutter. Oh, good thing wire strippers also come with side cutters. Found side cutters. Okay. Okay, and then just to... Oh, nice. Purple and yellow. From Hako? I thought they were blue and yellow. I hope that's not... I hope confusing blue and purple is not a sign of color blindness. Of course, purple and yellow might be a knockoff color. Oh yeah, it's tough. Like the official stuff is blue and yellow, but of course blue can also be faked. What did you end up buying, by the way? I recommend the 951 series of soldering irons. I have a 888, but I want to upgrade to the 951 FX 951, just because it can deliver more heat, which could be the difference between fixing something and not fixing something. It's kind of more suited to the lead-free kind of working or electronics that we tend to encounter. Just trying to think here. Ordering from Japan's not a bad source, to be honest. I was considering getting a desoldering vacuum from there. Oh right, that reminds me. I'm glad you brought that up because I remembered I received a counter offer on a desoldering vacuum, an FR301. Yeah. Now, how is this any clearer, or did I just make things worse? Let's just clean this flux off. Yeah, I guess it's just marginal. Yeah, I didn't make a dent in the area I wanted to, which was the balls, the where the Wi-Fi chip were. So where the Wi-Fi chip was. So what I'm gonna do is melt some lead on there and then suck it back up again. There, now let's get a new piece of. I think even if they are Chinese knockoffs, they should perform adequately. I've seen a lot of videos of Chinese origin equipment just being really not like stellar, having really stellar performance. Like I bought this LCR meter from banggood.com, and it's supposed to be like, it's so good that it's within like less than 1% of a Roden Schwartz, which is like a really top tier German brand. Yeah, that's flattening out better now. That should really reduce the glare when it comes to the photos. Oops. Okay. Oh. Okay, yeah, I have a 888D. That's interesting. You have a, yeah. Hot tweezers are nice. Oops. Yeah, interesting. Okay, so you got all the tools for. Oh, interesting. Yeah. So the AAA-D is a base, but you can, it only has one socket, so you can plug in like a soldering iron handle or a hot tweezer handle. Um, it, yeah. So it sounds like you bought hot tweezers, which is a really nifty tool to have. I don't know like a specific model number of hot tweezers, but I really kind of want hot tweezers myself because they are so handy. There, that's looking a little flatter. Okay, I think we can go for a shot number 2 here. Yeah, I'm just going to be obnoxious again and try to zoom in closer. Oh, I guess there's some hairs down there. Oh, okay. I guess I'm at optimal focus. Okay, let's just see. Okay, let's play back the last photo. That's looking a little better. I think this is informative enough. I suppose the previous photo has less debris, but I think this new photo is better focused, or slightly better focused anyways. Well, I can still, oops, I still have the same, so there was some debris somewhere around here. Let me just see. Clean off my iron. Just burn off any little hairs. Okay. Yeah, the thing is, the problem with Amazon is that they can still be cheap Chinese knockoffs, but they just set the price high. um, yeah, well, doesn't matter. I'm pretty sure that even if even if it is a knockoff, it will perform adequately for the stuff that most people want it to do, anyways. Okay, well, I have my photo, so I can have all the fun I want. Because there is a data sheet for the Wi-Fi chip, so I can pretty much assemble a schematic and then figure out what the heck this a working a working circuit is supposed to do. But you can see on the right hand side, they did provide like multiple paths for each of the signals to come out of. Oh, no. Hmm. Well, anyways, I better get on to more productive things. Let's see here. So I guess I'll put the little itty bitty Wi-Fi chip in a anti-static bag. When you have a chip on its own, it is in its most vulnerable static state. You'll definitely want to be touching an anti-static mat while handling it before it goes into the bag. Okay, so I've got a little DigiKey bag here. Well, it's not little, actually, it's ridiculously large to hold a single chip. But into the anesthetic bag it goes. Okay, well, that was a little fun exercise. Let me just take a pause. Just mute the mic because I have to take a bathroom break. Okay. Looks like Fat Corn had to leave. Oh well. Do. Okay, so. Oh, this might be a good time to move on to the keycard. So let me just change the scene here. Oh. Do I have keycard? Nope. Let's just load keycard first. Okay, I've got the schematic window open, but I have to make a new part. So let's see here. Oops, cancel. Oh, let's go here. No, yes. Oh, that's a scene thing. Whoops. There we go. Now what's going on with the... Okay, yeah, I thought this window would fit in here. Okay. For the most part anyways. Okay, so I need to make a part. So let me just Google that quickly. And unfortunately I won't... It'll be hard for me to watch chat. Okay, how to make a part. Keycard. Keycard 7. KLC. Nope. A lot of these keycard tutorials are like 4 or 5 years old. Jeez. Nope. That's just how to use the schematic bit. Okay, here we go. Well, I say that this could be outdated too. Alright. From schematic library editor. Oh, oops. Okay. Let me just go back to the main KiCad window. Of course, this interface is completely changed. Okay, so this tutorial is also out of date. Wow. How come these people are not staying up to date? Holy crap. Do I really have to watch a YouTube video? They couldn't do it in... Okay. Well, at least KiCad themselves have a tutorial. Symbols of footprints are organized in libraries. The library can hold both. Okay, file new library. What? That's not a file. Okay, open the simple editor from the project manager. Oh, okay. Okay. Is this tutorial also out of date? That's insane. No, they're saying this is version 7. Okay, what's going on here? Open the symbol editor from the project manager. Click File, New Library, and select Project. File. There's no new library option. I mean, new project? No. I mean, I can open I already created a new project for this switch extension. Okay, then... Okay, so I have a project open, but there's still no new library option. Frustrating. Open the simple editor. Okay, there's a simple editor. Okay. Then I should file new library. Okay, there it is. And then select project. Oh, well, I should make it a global library. Let me just make it global instead of project. Okay. Just call this... Okay. Okay, so I've created the new library. Now I have to do file, new symbol. No. In the symbol name field, what? Oh, I have to select, okay, so I have the New library selected. Okay, new symbol button.
Alright. It's about time for chaos. Y'all ready? Y'all ready to kill chaos?
Oh, I guess OBS hasn't caught up to which window I'm in. Here. Okay, creating new symbols in the library pane.
Let's go.
File new symbol. Okay. Enter the part number. Oh, okay. So what do I want to start with? I could start. I should find out the two part numbers for the Molex. Okay, this is back up here. This has got 30 circuits. Okay. Let's see here. There, okay. Oops. Okay. Da-da-da-da-da. Okay, creating new symbols. Okay, so I've already clicked that. Enter the part number. Okay. So I'm going to do the EMMC side first.
Funny that this particular
Where is that now?
physical effect
There. So symbol name.
beats and chaos.
Um,
Wrecks shit. More people. Otherwise,
got to make sure I've got the right part number here. Oops. Do do do. Okay, let me just see that. Let me get another photo of that. I guess I'm being followed by porn bots on Threads already. Oh well. Okay, let's just see here if these... I don't think these two photos are materially different. No, they're not. Okay, that's good. That means it'll just be my mistake when ordering the actual connector part number. Okay, so... 51338, is that what I'm... That's strange. Okay. So what's the actual part? Whoops. What's the difference between 55909? Oh, I see. One's thicker than the other. Ah. Okay. So this was probably 55909. Rotate counterclockwise there. Okay. Well, I guess I don't know. Okay, so the main board part number is 500-913 0302, whereas the EMMC board part number might be it probably is the 501745, but that's not very slim. I mean, the 55909 seems slimmer. Weird. The photos of 55909 seem a little more closer to reality, so I think that's what I'll call this part number. So this part is 55909-0374. Okay. Derived from existing symbol, none. Default reference so the reference designator. Oh, okay. So if it's an IC, then you put a U. Then if it's a switch, you put SW. So this is a connector. I'm gonna put a J. Units per package, I'm assuming, is 1. And I'm gonna leave everything else the same. Pin name position offset. I think that's pretty important, right? Why would you leave that default? Oh, pin name position offset. Yeah, okay. Show pin name. Okay. All right, let's just press OK on that. All right, so so it's JXXX or whatever, depending on how many you put in there. Okay. Yep. Move text out of the center to get it out of the way. Okay. Where's the move tool? Ah, here we go. Ah, okay. It's context sensitive. Okay, well, definitely away from the center anyways. Okay, add a pin. Okay, add a pin button. Oh, it's not visible. Oops, sorry about that. Pin name. Okay. Pin number. Okay, let's see what they want us to call these names. I think I would elect to just call it pin name. Maybe I'll just give it a number. Okay. You know what? Let's change this from. Is this the scene? Okay. Let's change this from remove and just make this display capture. Okay. There we go. Okay, there. And then you get to see all the background windows. Still wonder who our mystery viewer is, but I'm glad that you're watching anyways. Electrical type input. Oh boy, I have to know the pinout already? I mean, some of these are bidirectional, right? Switch eMMC pinout. Oh, good thing there's a switchbrew.org/wiki article. Let's see here. So if I rotate the board like that, they call this 30 through 1. Okay. So pin 1, 3.3. Yeah, that was certain there's 3.3 on this thing. Pin 1. It should be accepting 3.3, so it's an input. Graphical style line, sure. Yeah, we don't know. Orientation. Oh, hold on. I should probably read the article about orientation. Oh, okay. So the thin circle must be the where you lock onto in the schematic editor. Okay. So yeah, that's right. So I want it to be left. Yeah, because I'm going to be doing clockwise numbering as per the switch brew, whatnot, pin length. Sure. Okay, well, let's just keep making pins then. So pin 2, ground. Oops. Pin 3, also ground. I wonder if this will... I don't think this will make conflicts. Yeah, I didn't think so. Oh no, pin 3 is CMD. Oops. CMD 3. Okay. Pin 4. Pin 4. Ground. You know what? I should zoom. There we go. Let's see here. Pin 5, data strobe. Oh, interesting. They don't even know.
Wasn't the time loop explained in the space station, or was that just the power suckage? I mean, that's like the last minute of the game, basically. Like the last... That's the second to last dungeon, and they say there's a time loop. If they do explain it, they don't explain it to my satisfaction. Like, why did this loop prove to be the one that broke things? Why was this loop the last? What was happening in previous loops that caused it to sustain itself? That, maybe I'm just thinking about time travel a little too much lately, but...
I guess arguably I could make the other connector all outputs, so to speak.
Results screen yet? I'm not sure yet, but like maybe it will. I don't think so.
Let's see here. So pin 7 is DAT 4. 7. Bidirectional, really, but
Okay, music is real good.
this thing was really meant for mice. Where's the zoom? There we go. Okay, so DAT 4, ground, 5, ground. Okay, so this should be GND 8. Is there a key for this? Oh, P. Okay, good. So DAT 5 is 9. Might also be good if I get my glasses. And sorry if I'm missing any messages, but I don't think so. Nope.
It's unlikely I'm streaming tomorrow because I'm going to that New Year's party. today we're going to be doing more Grand Poo World 3. Hopefully make it a good level stream to make some real progress. Since this is around the end, I will do my spiel one more time. We are doing our incentives by what randomizers we have access. We have access to. As you can see over there, those are our two incentives. The first one is the sub incentive. We are at 13 out of 20. That once we reach 20 subs, we will unlock Super Mario 64 randomizer. So we only need 7 more subs for that. And then the other one is our Kofi goal. Once we reach $100 in that, we will unlock the Super Metroid randomizer. And we are $25 away. So if you want to sub to the channel or donate some subs, give some subs, that would be appreciated. My Kofi is up here, the link. If you want to click that and leave a tip if you enjoy what I do on here. That's it. Just I appreciate you all, and thank you for watching, and thank you for being here at all.
It's good pie.
So I know who we're gonna raid. Our good pal Aunt Thunder Fun is doing a 12-hour New Year's stream, so we're going to raid them. So y'all make sure to say hey to Aunt for me. Good person, good streamer. See you next time. Happy New Year.
Actually, yeah, we were both on left.
Wow, this seems a big.
What were you shooting it with?
Pizza, pasta, portage in a box. Silent Snake, hello.
Lost my place. Sorry about that. Oh, pin 10. Okay. Ground. Surprise, surprise.
How are we? What were you streaming? What were you doing? Final Fantasy. I love to see it. I have been seeing you in VC with friends.
Dat 6.
I want to join those.
All I can say is I really hope that this
But have you had a good stream? Welcome in, everyone.
Can like enemies do damage to other?
I really hope that this wiki article is correct. That's all I can say.
Could this game? Destiny 2 is a flawless game. Is a flawless game. I fell.
I wonder if there's anyone in science and technology that's worth watching.
Bring it here and put it on my cup. Ooh. Final Fantasy Pixel Remaster Randomizer. That sounds.
Live laptop giveaway. Ah, neat. Someone building a PC. Also as a giveaway.
Oh.
There's a streamer called Flat Earth Channel. Oh my god. Of course there's me. Interesting.
some 3D printing. Wonder if there's anything interesting on the PC building channel.
The angriest king. Okay, let's look at that.
At least there's some decent background music with Deus Quain.
Over the next 6 months.
Well, I think I'll leave it on Deus Quain just for the background music. Okay, where was I? And this is why I can never get anything done. Alright, GND 12. Wow, I can type. There we go. Ah. Okay, so 13 is DAT 7. Uh, 14 ground. Ah, 15 and 16 are 1.8 volts each. Okay. 1.8 volts. 15. 1.8 volts. 16. 17, 18 are both ground. Okay. 17. Whoops. 17. 18. That 2.
Where is that tool?
Oh, whoops. This is 30. Oh, shoot. Shoot, where's 15? Okay. I was like, this is the 30 circuits. That means that half of these have to start somewhere. Let me see here. So this guy is on the right. There. And then move. Is move an M button? Yes. Okay, good. There. Kind of? Does that make? Input. This seems wrong somehow. But, maybe it'll line up when I change out more of these. So this would be right. And then move. There. Okay. Okay. Right. I do not know why I have such a huge headache right now. Maybe it's because I don't work enough. Ooh, now I can put the J here. Okay. Can I do... Oh, hello. I've got to make room for all the text that will come up, possibly. Okay, now I can use the P tool. Alright. Where was I? 21. Whoops. P. Okay. 21 is dat 1. I wonder if they took a board scan of this. I should look that up. Because, like, the only way I see this being implemented is it could be just a dual-sided board, but it could be multi-layer.
What the hell? Is that what from the lightning storm?
Actually, well, no, that wouldn't tell me anything. I guess the only way to find out is to just desolder one, completely disassemble one, and then file it down. Well, this could be a very involved project, but or a very fun project. Shoot, where was I? 22. 22 is ground.
I'm debating on whether or not I want to actually do this, or if I just want to
23, dead 0.
put them together.
Yeah, dead 0. 23. Okay, 24 is ground.
We just do this. Probably a good idea.
25, dat 3.
And then the real question is we want to make sure that these are the opposites.
Ground is 26. Clock. Oh, there we go. 27.
Because then we don't want to.
Ground 28.
Wow. Sweet. Did you use Sharpie Be Gone?
Okay, so 29 and 3.3 volts, 30. All right. Okay, so I can cram these together a bit more. There. Oops.
I'm
And
gonna have to try
then,
that.
let's see. I think that should be safe. Sure. Alright, now, there we go. Is that centered? I think I can move it a bit more. Let me see here. I think that's fair. Okay, let's just save that. Okay, made all the pins. Now what? Oh, sorry if I missed any messages there. Oh, well, welcome back. Did I solve my problem? I don't know what my problem was. I'm not thinking about the Wi-Fi at the moment, but let's see here. Yeah, no, I'm just making like a. Let me explain the other problem I'm trying to solve. Just fire up my camera. The problem is, let me just turn down this other stream too. I've been using this other stream as like background music. Okay, so let's just turn this back to. So basically, one big thing that keeps people from working on the Wi-Fi with the Switch is that. Let's see here. Where's the other motherboard? Here we go. So basically, as you know, Wi-Fi is under an RF shield, which is whereas this is the frame. And if you sort of go over here, this is where the storage, the 32 gigabytes, gets stored, or that's where the connector is. So they made a little daughter board, which has your 32 gig chip, but at the same time, the shield is glued. Well, it's not glued. You see the double-sided tape is attached. So basically, if you're trying to troubleshoot the Wi-Fi, you have no chance in heck because this is connected. So what's a technician gonna do? What's a technician supposed to do? My idea was it should be safe to make another board which would let you plug it in and which would let you plug in the storage somewhere over here. So you have I'm trying to make a new board that would go from here to here. And that's what you're seeing. Oh, shoot, you can't see any of that. Sorry about that. I'll start over. Okay, I have to go here. There we go. All right, so in that case, I can actually go to chat. Okay. Basically, so yeah, the crux of this problem is that you've got your Wi-Fi. You want to poke at it with your multimeter, and this is where storage goes. But the thing is, your switch doesn't necessarily turn on without the storage connected. So what if you wanted to poke at the Wi-Fi while your switch is turned on? The reason why you can't poke at the Wi-Fi is because when you have your 32 gig chip connected, this whole area is just covered up. So I said, why not make a sorry. Why not make a board? And it should be safe, I think. If the board's only like a quarter of an inch or a half of an inch, there should be a board. I should be able to lay out a board that goes from here, that connects here and connects to the storage board, and lets you install it this way. And that would let you poke at the Wi-Fi because the cage is open now. Ideally, if I could even stretch it out by an inch, then you could, like, ideally I'd be able to rest the board somewhere around here. So maybe like a Z-shaped board or a 45 with a few 45-degree bends in it would be ideal. And that's looking like an inch or more. But yeah, that's the dream anyways. So yeah. So what I'm doing is I've got to do the sort of boring work of creating the schematic and the parts and the layout, and yeah. So yeah, hopefully I can pull it off. Now let's see here. I'll just turn off the camera so it doesn't distract me now. Well, unfortunately, I can't. Well, I guess I could. Oh. Well, that's what I'm trying to make. The thing is, I can't find an existing product. I don't know if anyone's tried. I can't find any attempts at people trying this kind of thing. So that's why I thought I would just step up and do it. No, this is I think this is really a Nintendo choice. They want to make this thing as tiny as possible. I mean, if you put the storage in on the main board, then you've increased the main board size by, probably looks like a square inch, maybe. I would estimate it would increase the board size by a square inch, which of course they didn't want to do. So I totally understand, like, from a manufacturing point of view, why you'd want to do it this way. But when things go wrong, then you don't have a repairability. You don't have repairability factored in, and then I guess that's where people like me come into play. What I can actually do, because I'm doing display capture, I can actually just, let me see if I do that. And then this. And then I can actually change the sharing. There we go. Now I can't ignore chat. I guess technically I'm ignoring YouTube if anyone's watching. But I don't think so. Okay, so that takes care of the pins. Now I've got to read how to... yeah, exactly. Well, anybody who wants to go into repair, because I wonder how many people just blindly replace. I mean, I think some people just blindly replace chips, the Wi-Fi chip, as a final solution, and then there's no real like diagnostic capability when it's covered with a shield, right? You just say, "Oh, I think the Wi-Fi is malfunctioning. I'll just replace everything under there." Or I'll just replace the main chip or something. You just don't have enough insight when the shield's on there. Let's see here. It could be a moot. It could be a moot issue because if 100% of the time it's just the Wi-Fi chip, then maybe this is a waste of time. Well, that's the mentality of most repair people. But how do you, like, you still need to, I guess most repair people, like, there seems to be a layer that I don't have access to in terms of repair, right? Like, there is a reverse engineering aspect that I don't seem to have met in terms of, like, people, collaborators, etc. But I mean, there's always the situation like with PlayStation 5s and Computer Booter last night basically spent 3 hours swapping PlayStation 5 CPU, and then it didn't fix it. But the thing is, we have no how do you say it? We just don't have, like, there's just not enough reverse engineering knowledge amongst the community to actually understand what the root cause was. Let's see here. So after you make the pins, besides, I really need an excuse to learn KiCad. Okay, graphical features. Don't really need those. Let's move on. Symbol properties. Okay, file, symbol properties, double clicking on the canvas, change the value. Oh, I see. Okay. So this is the Molex. What did I start with? This was the 55909. I think I started with the daughter board. Yes. Okay. So this is the Molex switch. Let's see here. I don't intend to do much with this yet. Let's move on. Okay, so no, move on. Create new footprints. Okay, good. Save it and move. Okay, save. Open the footprint editor and create a new. Okay, does that mean I close this window? I assume so. Footprint editor. Okay. Okay, footprint editor.
Yeah, it's 110. If I really wanted to go crazy, I got some BSoD.
Similarities new footprint decided. Okay. Hmm. Organization. What is that? Let's see here. Okay. Okay. Footprint. The switch has 2 pins, and oh boy. Oh, right. Okay, what kind of units do they work in? 0.4 watts. Millimeters. Okay. So it looks like I need hundredths. Yes, I'll need hundredths of a millimeter. So view grid properties. View grid properties. Sure, 0, 0.01, 0.01. Okay, sure. All right, now. Well, actually, no, that's 6.3. Yeah, 0.01's got to be correct. Okay, now what? Add a pad tool. Okay. Oh, nice. Okay. I'm assuming that's what this is. Okay. Boop. 3, 4, 5.
I can't even test this because the friggin' light bulb is already fucked.
Okay, and then I've got 4 anchor pads. 1, 2, 3, 4. Okay, so there should be a zoom all button. There we go. So I guess I've got to type in the dimensions now. Okay. So they're looking for perfect squares, and it's 22 millimeters tall and 0.9 millimeters wide. Worry about position later. Round rectangle? No, just rectangle. X, where they, I guess they're going, so it's 0.9. Y. 0.22. Okay. Angle 0. Yes, that makes sense. Yes, okay. Wait a second. That can't be right. We've got a dimension problem here. 0.4. Wait, 0.22 millimeters. Dimension units are millimeters. 0.4 pitch. My grid is way too huge for what I just input. Okay. Sorry about that. I forgot to adjust this window size again. Let's try this again. There we go. Okay, so I've got to fix this grid. View, show grid. That might help. No, it's not showing for some reason. Okay, grid properties. Yeah, that's right. So maybe I should just do that and that. So I'm forced to use one grid. No, this can't be right then. 0.01 millimeters. Hold on a second. Yeah, this is right. Huh. Oh, hey. No, this is, Oh, sorry, yeah. The math is not mathing. Well, the software is just misrepresenting something here. I was thinking the grid size should be fractions of a millimeter. Let's see. Yeah, user grid. Okay. Let's just go to the user grid. Press OK. And it's still snapping to this weird ass. How come that's not... Units. Millimeters. Yes. Like, you can see at the bottom... you can see down here. Like, I'm trying to make that every crosshair jump 0.0 something. You didn't set the second option of the grid correctly? Oh, okay. Grid. Use. Oh, I see. Well, they're supposed to be the same grid, but I can select user grid again. No, it's something else. I don't understand. Is it a property of the library? Whoops, cancel. Let's save. And this shouldn't even get into it. Oh! That's better. Okay. The active grid is here. Okay. Okay, that's better. Now I can actually go here, and eventually I can actually see the grid. There. Oh, have a good night. If you want to see when I come online, well, I stream every Wednesday and Wednesday through Sunday, 6:30 p.m. But if you want to follow, just to get notifications when I go live, let me know. Or go ahead. I'm also on Twitter and Blue Sky. Okay, perfect. Well, have a good night, Fat Corn. Yeah, sorry. How's your holiday been, Arcade Bear? I'm glad you came by, or I'm delighted that you came by. You missed, Oh shoot, what's going on with my mouse now? Is my battery dying? Aw, come on. Oh, there we go. Alright. Oops. M. There we go. Hold on. M. Do I really have that much freedom? I must be doing something wrong. Well, you know what? Maybe I should just worry about the properties of the rest of these. So this would be 0.9, 0.22. 0.9, 0.22.
Do not attempt to defeat the safety feature. Talking about polarized wood. Like, okay. We're not. We're just gonna bypass this bloody thing altogether. Putting this to longer cables like this.
What was I gonna say? Sorry. Oh, Silent Snake was streaming Final Fantasy Pixel Remaster randomizer, which I thought was kind of fun. Oh, I guess you took off. Oh. Oh, you were lurking. Okay. Yeah, I caught him right at the end. Let's see here. 0.9, 0.22. Nine, 2. So is this grid correct then? I should. You know what? Might be easier if I move this to 0, 0. And then I'll just make everything relative to it. So, negative. What was the pitch? Negative 0.4. 0. There. Oh, there we go. Okay. Right. Let's try this again. 0 minus 0.4. Much better. Okay. Then I can do this guy. 0 minus 0.8. 0 minus 0.12. I guess I'm not mathing correctly. Oh, minus 1.2. No? 0, minus 0.8. The next one should be minus 1.2. Okay, there we go. I must have not typed it in properly. 0, minus 1.6. Okay, that's looking good. Oh, shoot. That's better. Okay, then this would be 0, 2, oops. Oh no. I had to. What was I doing? What was I? Oh, right. I couldn't figure out where the failure was. So the only I think by process of elimination I isolated it to the Wi-Fi chip. It's either the Wi-Fi chip or the SSD storage. But in order to properly poke at the Wi-Fi chip, you have to relocate the SSD sort of daughter card. Let me see here. I'm just going to switch scenes here to HDMI capture and press play. Okay, so basically, this is how it would come from the factory. So the RF shielding here, and the SSD daughter board are one piece. So when I pry it off, then you get to poke at the Wi-Fi circuit. The problem is your switch will not boot if your storage is not connected. So to get around that snafu, I was going to create a board which would let me connect the storage over here to join these two. Then if it works, because an inch is quite a big distance in terms of this kind of signal, then I can actually poke at this while the switch is trying to boot. But yeah, the other thing was a sort of a, not a colleague, but basically a fellow repair person I was watching last night, or the night before, swapped out this Wi-Fi chip, but it didn't work right away, and they couldn't figure out why. So part of the stream, I actually took a photograph of a dead. I basically used hot air and blew away all of the, not blew away, but used hot air and removed all of the Wi-Fi components. So now I can sort of construct the circuit and possibly offer, and if I can create some sort of document, then it would tell you how to trace through, this area to actually figure out what's wrong, what is going wrong. So I have that photo. I have a photo of this, but I might later on take a photo of this so I actually know what the components at least look like. But I think in this case, I do think the chip is dead. Just the chip. But like I say, I can't get the rest of the switch to boot, I think, unless the storage is connected. I mean, if the storage is dead, then I think the whole board is not salvageable, because your storage is married to the CPU. No, sorry. Your storage is encrypted. I'm thinking of the PS5. For a Switch, your storage is encrypted with keys that are stored on the CPU. You can back up those keys if you hack the switch, in which you can create another encrypted, like if you just bought another chip off the shelf, you could re-encrypt and create a new storage because you have the encryption keys. But this is a catch-22 because this switch was malfunctioning before I could get the keys off. So yeah, this, if there's, I guess, yeah, I guess the other thing too is like the storage and the Wi-Fi have to work, or else your Switch doesn't boot. Yeah, hopefully, hopefully I explained it well. I think the battery's dying on my keyboard, or is it just it's just the position on the desk? I don't know. But yeah, basically, if you can't, I suppose, if you can't get the storage to work anyways, then you're kind of screwed no matter what. And perhaps this board is not worth pursuing. But I thought, if the only thing that's malfunctioning on a Switch is the Wi-Fi, and you actually want to know what the root cause is, the only way to figure that out is to relocate this board, essentially. So yeah, I guess this PCB might still be worth laying out, but yeah, sometimes a little bit of thought into what's actually going wrong with the Switch would keep you from going into large rabbit holes. Now, where was I? Yeah, unfortunately, we've got a lot of tedium here. That was 2. Okay, so the next one is going to be 2.4. So in a PS5, yeah, unfortunately, the storage is tied to the storage controller, which is tied to the CPU. So yeah, if your storage fails, let me think here. If the storage itself fails, then I think you can replace the chips and then rebuild. But if your SSD, if the actual storage controller fails, then you're screwed. That's right, because the SSD controller is paired to the CPU. But I think the actual individual NAND chips are okay. No, unlike in the PS3, they got so deep into the internals, the reverse engineering advanced so quickly, or so deeply, that they're actually able to make an easy way to pair, I think in that one only the Blu-ray drive was paired to the CPU. So they actually found a way to just use a bunch of USB keys to let you pair any Blu-ray drive to a CPU in a PS3. But as they went on in the generations, they just kept locking it down more and more. I don't even know, I don't even know why they went with a custom SSD controller in the PS5. There's no games that use it. It's really sad. 2.4. I think that's right. Looks right. Okay. So 2.8. Yes, okay. Let's see here. 3.2. 3.6. Oh, shoot. Sorry, you're stuck on this scene. Boop, boop, boo. There. I forgot what millimeters I'm on now. 3.6. Okay, so 4 millimeters. So 0, 4. 0, 4.4. 0, 4.8. Rectangle 0.9, 0.22. Let's see here, 0, 5.2. Oops. No. Oh my goodness, really? 0.92. I think I'm at 5.2. Leviosa. All right, 5.6. Oh, right, the extra pads are for anchors. 0. Shoot, was that 5.6? Dongs. 0.9, 0.22. Okay, well, I should. Let me just get the dimensions of this anchor while I'm already here. Ooh. Okay, so you are 0.5 high and 0.85 wide. Okay, now you're physically located where? Oh my goodness. Oh, I'll just figure it out later. Okay, so you are a rectangle. It is 0.85. No. 0.5. There. All right. Okay, so relative to the first row, or relative to the first column, the second column is negative 1.73. Okay, so position X, negative 1.73. 5.6. I forgot already. Rectangular 0.9, 0.22. Awk. Let me just check. Yay! Okay. So minus 1.73. An email. Oh, a notification? Ooh, a porn bot has requested to follow you. So many porn bots on Threads now. Ooh. I'm currently watching a hot beardy guy on the Science of Technology. Oh shoot, where did my mouse pointer go now? Did my mouse die? There we go. The battery must be on its last legs. 5.2. Let's go to rectangular. 0.9, 0.22. Okay. Just making sure. Okay. Short-term memory is still good. 4.8 minus 1.73. 0.9, 0.22. Rectangular 0.9, 0.22. 3. Oof.
And this is partially because I'm so used to dealing with
Let me see here. So it would be 4. Nope. 3.6. This would be 0.9, 0.22. Okay. Just check that I haven't lost count. I haven't. So this would be 3.2 minus 1.73, 0.9, 0.22. Minus 1.73. Oh, shoot. I did lose count. 0.9, 0.22. Okay, just press up. Of course I can't press up. Alright, I actually need to know what the button I need to press is. No. 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 Let's try it that way. Haha. Shoot, if that was 3.2, that must have been 2.8, which means that this should be 2.4. Point. Ooh, alright. Let's see here. Point. 1.2, 0.8. Yeah. 1.73. 0, I guess, for now. Let's see here. Oops, rectangle. 0.9, 0.22. Okay. Alright, so I don't know where to put these yet. It's still a rectangle. 0.85, 0.5. Now, let's see here. Rectangle. 0.85, 0.5. Okay, now to reinterpret this drawing. Okay, so they're saying that the center of this rectangle is 0.8 from the center of this rectangle, vertically speaking. Let me think here. I think, did I make this 0, 0? I did. Okay. So, shoot. Of course, what I don't know is the center must be 0, 0. Yes, okay. Okay, so that means... Oops. That means I can move it 0.8 minus whatever this height is, 0.22? Right, minus half of 0.22. Okay. So the y is... I've got to get a calculator here. Okay, so 0.8 minus 0.11. 69. Nice. Minus 0.69. Okay, so in the x dimension... 0.63 divided by 2. Oh my goodness. And then that's... Okay. Okay, so this is point... Okay, this will be interesting. These are all 0. Okay. Oof. 1.73. How did I get... Where did I get the 1.73 from? Oh, that is 1.73. So then what are those dimensions? Oh. Yeesh. Oh my goodness. Okay. Okay, 1.73 divided by 2. 0.865. Okay. So what I'm going to do is move... Oh, I should move all of this stuff. There. Okay. Then... move... Oh, whoops. Move exactly in the... Let's not move it height-wise at all. So the center of pad 1 is 0, 0. I need to move that. Oh, it's 10:30 already. I guess I could continue this tomorrow. Might be good in terms of average viewer count. Oh, thanks to everybody who was watching. I'm going to end it now so that my viewer count doesn't drop anymore. Let's see here. Oops. I have to go to odds. There we go. Well, have a good night, everybody. And Happy New Year? No. If I don't see you tomorrow, Happy New Year. Bye-bye.